Today I want us to look at the substitution method of integration. Basically, when we want to integrate algebraic function, for example, let's say we have the integral of 2x to the power 5 dx. We want to integrate this. To integrate algebraic function, what do? We write this to the power 5. So what is next? We add 1 to the power. Originally, the function comes with a power of what? 5. So if you add 1 to this 5, it will become what? 6. That 6 is what you bring down. This is integration. The rest is just simplification. The rest is just to simplify. 1 over 3 x to the power 6 plus c plus c. Suppose there are no limits here. Yes. So this is the basic integration. Sometimes you will have a case like x into x squared minus 3 dx. We have a function of x, we have a function of x. So there are two functions of x. So sometimes we have substitution method, but beginners sometimes find it confusing when you try to use another method other than the traditional or the general method. So what we usually do here is we expand. This will give us x cubed. This will give us 3x dx. Then we can use it. We add 1 to the power to get power 4. We bring down that power minus 3x. Here is 1. If you add 1 to it squared, you bring down that 1. Then we simplify if this side. All right. But sometimes you have functions like you cannot unite, you cannot bring them closer. We have a function of x, the root, we have x here. Yes. So we cannot unite x. Even if we try to unite x by writing x here and say x squared plus 1, we apply surds. When this one goes in, it becomes x squared with a bracket, then x squared plus 1. So it becomes higher. So once it becomes higher, you find it difficult to have what? A well simplified result. Okay. So what do we do now? So situations like this, you'll be forced to use the substitution method. So let's see how we use the substitution method. We have the integral of the root of x squared plus 1. Here is x dx. Okay. So using substitution method, you need to bring in a new variable. And that new variable, once you bring it, you'll have to convert every x variable to the new variable. But mostly we use u to represent the new variable. But it doesn't mean that it is compulsory for you to be using u. You can choose to use any other variable. The only thing we mostly avoid using O because O resembles or appears like 0, especially handwritten. Okay, so what we do is let's go inside the roots. And we say what is the new variable? Let's say let u equal to x squared plus 1. So the fact that you've let u equal to x squared plus 1 by bringing in a new variable, you have to make sure that everything becomes u. So what do? We have u equal to x squared plus 1. Now, in this case, if u is equal to what is here, it will become the integral of the root of what is in the root, x squared plus 1. But x squared plus 1 is already what? Is already u. And this is what? This is x dx. But as I just told you that everything has to become u now. You need to convert everything to become u. But this is still x. and this is still dx. So for us to avoid this, to still eliminate this, let's come to this. We'll say, but now we differentiate u against x. We say du over dx. Now we are differentiating what? U against x. Pay attention, please. I will make sure that lesson 13 is also about substitution. If possible, lesson 15, 14 again, about the same substitution. All right. So now, as I just said that once you bring a new variable, everything has to become that variable. So this is root of this expression, but this expression is u. So root of that u. But we are yet to see this become u. So we differentiate this. Du against dx. If you differentiate this, what do we get? We get 2x. Remember differentiation. If you differentiate this, what do we get? We get what? We get 0. So we don't bother. I hope it is clear. But this is our concern here. Yes, this is our concern, like what we usually see, a red flag. We don't want to see x dx. So what do? We give this 1. Du times 1 du. Dx times 2x is 2x dx. Dx times 2x, 2x dx. Du times 1 is du. Our problem is not 2. Our problem is x dx. X dx. Our problem is what? X dx. So what do? We divide both sides by 2. Here is 2. So this goes away with this. So x dx is equal to 1 over 2 du. I hope it is clear. So therefore, our integral now becomes root u. Yeah, between root u and x, there is a multiplication times what is x dx? X dx is half du. So this is half du. Okay, please don't be surprised that as long as this is a single term, the constant we usually send it out. So it becomes half the integral of the root of u du. So I think we've succeeded in letting everything becomes what? The new variable, which is u. I hope it is clear. Okay, so now this is like the usual integration, which is half the integral of u to the half du. So half. How do we integrate? To integrate, we add 1 to the power. And the new power is what we bring down. Half plus 1. But mind you, 1 is a numerator. 2 is what? A denominator, right? So in that case, there is half outside. In that case, this 2 goes down. So at the top we have u. Okay, don't forget plus c. Half plus 1 is 3 upon 2 over half plus 1, 3 upon 2. Don't forget 2 is coming down. I hope it is clear. All right. This takes away this. We are left with 1/3 1 over 3 u raised to, oh, please do not forget 3 upon 2. I can forget, no problem, because no one is marking this one as an exam or marking a script. Do not forget the exams, because this is what indefinite integral. Okay, so this is what we have plus c. So 1/3. Okay, what is this? 3 upon 2 plus c. But the question is, can we have this one as our final answer? No, because the examiner does not give you, or the question paper does not come with you The crossover comes with x. Yes, so go again. What is u? U is x squared plus 1. U is x squared plus 1. So this is the result. This is all about the substitution method. But the most tricky part of the substitution method is knowing the part that you must let to you. You must let to be you. And once you know it is you, then how can you dismiss the dx? That is mostly the problem. Yes, this one comes with x here, but sometimes it doesn't come with x. It will come with what? Just a constant number. Okay, so I will try the next lesson to be also substitution. Thank you for watching. Don't forget to follow, like, share, and comment. See my next video.